In a previous video, we talked about determining whether or not two functions were inverses of each other. And now what we're going to do is we're going to try and find explicit inverses just given an initial function, okay? So here we have h of x is equal to the points -9, -1, -8, 1, 4, 9, and 9, -9. Okay, so it's important to understand here that the x inputs are -9, -8, 4, and 9. And -9 has an output of -1, -8 has an output of 1, 4 has an output of 9, and 9 has an output of -9. Okay, so that's sort of what we're doing here. So if we want to find the inverse of a function, then we have to flip the order of those points. Okay, and we'll explain this here in a minute. So this is going to become -1, -9. This will become 1, -8. This will become 9, 4, and this will become -9, 9. So that's really all you're doing when you find the inverse function is you're taking the outputs and you're sending them back to the inputs. So if we have h inverse of -1, this is going to give us h of -9 because h inverse of -1 is -9. The output for -1 is -9, and h of -9 goes to -1 up here. Okay, so how we saw before, if we have h inverse of x has to be equal to x, this should be the case here. We can check for each one of these points that that is actually going to hold here. So this is a more explicit example, I guess, of exactly what's going on when you do the inverse of a function. Let's try this one here. P of x is equal to -1, 4, 1, 3, 2, 1, and 4, 6. Okay, so let's start by flipping all of the points. We have 4, -1. We have 3, 1. We have 1, 2, and we have 6, 4. So if we wanted to confirm this, we could check one of the points. You really should check all of them if you're going to truly confirm this, but that really shouldn't take too long. We have P of P inverse of 4, and if this really works as an inverse, we should have 4 as our answer, right? So P inverse of 4 is -1, so that'll give us P of -1, and P of -1 is 4. So if we were to check this for each of these, and it would work for each of these, then we would see that this is in fact the inverse of P. Okay, now these are exciting and all, but the more valuable way of finding inverse functions is when you aren't given an explicit set of points. Usually, you have some continuous function where you couldn't actually write all of the points that are involved here. It's easier to write it as some kind of expression. Okay, so we have a four-step rule for finding the inverse of a function. Okay, so we start by replacing f of x. If we're given a function f of x, we start by replacing f of x with y. We switch y and x. We solve for y, and then we replace y with f inverse of x. Okay, so let's see how this plays out in practice. Okay, sounds like it's a lot. It really isn't that bad. So here we have g of x is equal to -9x minus 13. So if we take a look at the first step, we're going to replace our function. In this case, it's g of x. We're going to replace it with y. So step one is going to give us, we'll actually just write these out. Step one, we're going to replace g of x with y. So we'll have y is equal to -9x minus 13. Step two. So here, we're going to switch x and y. So what I mean by this is anywhere you see an x, you're going to make it a y, and anywhere you see a y, you're going to make it an x. So this is going to give us x is equal to -9y minus 13. Okay, step three, we're going to solve for y. Okay, so here we can add 13 to both sides, and that's going to give us -9y is equal to x plus 13. Okay, and then we can divide both sides by -9, and that's going to give us that y is equal to x plus 13 over -9. Okay, and then from here, now we do step four. we're going to replace y with our inverse function notation. So here we're going to have g inverse of x is equal to x plus 13 over -9. And if you want to check g inverse and vice versa, you can to confirm these actually are. But if you're given a one-to-one function, you are pretty much guaranteed that this method is going to work for you. Okay. Okay. So now let's check this one. We have f of x is equal to x minus 8 over 7. So step one, we're going to replace f of x with y. That's going to give us y equals x minus 8 over 7. We're going to switch them. So then we have x is equal to y minus 8 over 7. And now we're going to solve for y. So we'll multiply both sides by 7. And we'll get y minus 8 is equal to 7x. We can add 8 to both sides. And we get y is equal to 7x plus 8. And then lastly, we can replace y with f inverse of x. So if f inverse of x is equal to 7x plus 8. Okay. Now let's take a look at this one. P of x is equal to 2x over 6 minus x. Okay. So if we want to find P inverse of x, we start by replacing P of x with y. So we have y is equal to 2x over 6 minus x. Then we're going to replace x and y. So we're going to have x is equal to 2y over 6 minus y. Then we're going to solve for y. So let's see what we can do. We can multiply here, I guess. Let's see what would be the best way to do this. We can multiply both sides by 6 minus y. Okay. All right. So these will cancel, and now we have 6 minus y times x is equal to 2y. Okay. And then from here, I guess we can distribute. We have 6x minus yx is equal to 2y. Okay. And then so from here, we can go ahead and take, let's see, the best way to do this. Let's go ahead and add yx to both sides. Okay. So we have 6x. 6x is equal to 2y plus yx. And then what we can do, should give myself more room here. And then what we can do is we can go ahead and pull the y out from both sides, or from the right side here. So we have 6x is equal to y times 2 plus x. And then we can go ahead and divide both sides by 2 plus x. Okay. These will cancel, and we're going to get that y is equal to 6x over 2 plus x. And then from here, we can replace y with P inverse of x is equal to 6x over 2 plus x. Nice. Okay. Okay, here we have q of x is equal to 2x minus 4, or sorry, 3x minus 4 over 2x plus 3. Okay, so if we want to find this, we can start by replacing q of x with y. So we have y is equal to 3x minus 4 over 2x plus 3. Then we'll have x. We switch x and y, we'll have x is equal to 3y minus 4 over 2y plus 3. And then we can solve for y. So let's start by multiplying both sides by 2y plus 3. So these will cancel, and we get 2y plus 3 times x is equal to 3y minus 4. So now let's distribute that x. That's going to give us 2yx plus 3x is equal to 3y minus 4. Okay. So, let's see. I guess we can, let's see. Let's pull the 2yx to the other side. Be the best way to do this here. Yeah, let's do this. Okay, we'll take 3y away from the right side here. Sorry. Sometimes it takes a second to think about how to handle these, but we're good here. So we'll have 2yx minus 3y. Okay. And then if we take 3x to the other side, we're going to have negative 3x minus 4. And then from here, we can factor out a y. So we'll have 2x minus 3 is equal to negative 3x minus 4. Okay. So then we can go ahead and divide both sides by 2x minus 3. Okay. And we get that y is equal to 3x minus 4 over 2x minus 3. Or we can rewrite this as q inverse of x is equal to 3x minus 4 over 2x minus 3. Okay, here's something a little different now. A couple left. So let's make a lot of space. We have r of x is equal to 2 plus the square root of x plus 9. So the same principle is going to apply here, okay? So we'll start by replacing r of x with y. So we have y is equal to 2 plus the square root of x plus 9. And now we need to switch x and y. So that'll give us x is equal to 2 plus the square root of y plus 9. Okay. And then from here, we can take 2 away from both sides. So we have x minus 2 is equal to the square root of y plus 9. And now what we can do is we can square both sides. Okay. So x minus 2 squared. If we write this out as x minus 2 times x minus 2 is equal to y plus the square root of y plus 9 squared. Well, the square root of y plus 9 squared is just y plus 9, so we can just leave that as is. Okay. If we FOIL this, we'll get x squared minus 2x, so minus 4x plus 4 is equal to y plus 9. Then we can take 9 away from both sides. All right. And then we're going to get that y is equal to x squared minus 4x minus 5. Okay. Alrighty. And then, or you can rewrite this as our inverse of x is equal to x squared minus 4x minus 5. Okay. But we have negative 5 and 1 should be a good way to factor this, right? So we could have x minus 5 and then x plus 1. Okay. So negative 5, and then we have, yeah, that should work, right? So that's the factored version of this. So we have r inverse of x is equal to x minus 5 times x plus 1. Not bad. Okay, and then on this last one here, we have a of x is equal to the cube root of 2 minus x plus 4. Okay, so same principle is going to apply here. So we'll have y is equal to the cube root of 2 minus x plus 4. Okay. So we'll have, take 4 away, and we'll have y minus 4 is equal to the cube root of 2 minus x. Okay. So we can start by cubing both sides. Okay, so we'll have y minus 4 cubed is equal to 2 minus x. We can take 2 away from both sides, and that's going to give us negative x is equal to y minus 4 cubed minus 2. And then if we divide both sides by a negative 1, we're going to get x is equal to y minus 4 cubed, negative y minus 4 cubed plus 1. Okay, and I actually forgot to switch x and y. You can do that at the last step, but you can interchange. Really, if you wanted to, if you want to go back to the top here, if you forget, you don't have to go back and start over. You can interchange these two here if you need to. So notice I just did that. I solved for x, but now I can just switch x and y. So this is going to give us y is equal to negative x minus 4 cubed plus 1. Now we can switch the inverse to the inverse. So we have a inverse of x is equal to negative x minus 4 cubed plus 1. And you can leave it like that if you want. If you want to expand out x minus 4 cubed, that is fine, but it's also probably okay just to leave it as